All right, hey everybody, welcome back to our second video lesson, 1.2. This is consecutive integers and age problems. All right, these are going to end up being like solving equations, all right, but we have some unknowns. We're talking about numbers, we're not sure what they are. Okay, we'll get more into that in a second, but I want to talk about notation first. So consecutive integers follow each other in order. Okay, so 1, 2, 3, 4, -3, -4, -5, -6. Okay, we don't skip any. So the algebraic notation for that, your first number, wherever we start, we would call that n. Okay, so in this example here, n would equal 1. Okay, but we don't know that when we start, okay, because that's our variable. Now, in order to get to our second number here, we have to add 1 to our first. So this is n plus 1, because 1 plus 1 equals 2. Okay, to get to our third number, how do we get from 1 to 3? You had to add 2. So that's why this is n plus 2. Okay, and the pattern continues. So for regular consecutive integers, so I do like to add regular. All right, your first number is always n, and then each subsequent one after that, n plus 1, n plus 2. Okay, now we do talk about even and odd, so that means that we're skipping numbers, right? Because even is every other, and same thing with odd. So it just depends where we're going to start. So let's think of an example here. So some even numbers. Okay, we could go 4, 6, 8, 10. All right, so evens, our first number is still n. Even and odd, okay? So if 4 is my n, how do I get to 6? I add 2, because I'm skipping 2 places in line. How do I get from 4 to 8? It would be n plus 4. You have to skip 4 places to get to that next even number. Now, even and odd notation is the same, because if we think about odd numbers, how about 1, 3, 5? Okay, so 1 is my first number, which makes it my n. How do I get from 1 to 3? I add 2 again. How do I get from 1 to 5? We add 4. Okay, so even and odd are the same. N plus 2, n plus 4, because our first number is what really matters. If you start at an odd and you skip 2 places, you're going to be at an odd number again. All right, so let's look at some of these problems and see this in action. All right, so we want to find 3 consecutive integers whose sum is -15. So is tells me that this is going to be equals and that we're dealing with an equation here. So find 3 consecutive integers. That means regular. They're not specifying even or odd. So our first number, our first consecutive integer is always n. So I want you to write down that notation. What will our second number be? Okay, our second consecutive integer should be n plus 1. And our third consecutive integer should be n plus 2. That gives me 3 numbers. Well, it says their sum. What does sum mean? Sum means add to find the total. So, n plus 1, and then add my n plus 2. Those are my 3 consecutive integers. Equals -15. All right, so we're going to combine like terms. Let's see if I can change color here. So n, this gets me 3n, and then 1 and 2. This is plus 3. All right, so take a second and pause if you need to, and just kind of digest what we just did with our notation here. So you always start your first integer is n, and then you determine, well, are they talking evens and odds, or are they talking regular? So then it's the next is n plus 1, and then n plus 2. All right, and the other thing, we probably should have mentioned this earlier. Remember, integers are whole numbers. That means no decimals, no fractions. So when you get your final answer, aside from going back and checking it in your equation, we also know that this is going to be correct if you get a whole number. All right, so we can solve this now. So subtract 3. Just going to scoot over here for some more room. What do we have? -6. Okay, so now -6 is not my final answer. -6 is just my first integer. There are 2 more. You have to make sure that with these types of problems, you list all of the answers. So you could take your n and substitute it back into each one of your notations. Okay, so our final answers here: -6, -5, -4. Okay, and the way that you could check your answer is add them up and see, did I get -15? Okay, now an important thing to note, guess and check method will not be accepted for these type of problems. Okay, I am looking for your equation, I'm looking for your consecutive integer notation, and I want to see you solve. Okay, that is what I'm checking here. That's the method. All right, let's try another one. So the sum of 3, okay, again, let's note that, that's important, consecutive even integers is 48. Okay, well, regardless of what type of numbers, our first is always n. And now if they're even, the second will be n plus 2, and the third will be n plus 4. And now we can make an equation out of this. Okay, it says their sum, which means I need to add them together. So again, combine like terms, 3n plus 6. All right, and now we are ready to solve. Okay, so n equals 14. Okay, but remember, that's not your final answer. You want to plug it back in to your notation. You need all numbers. An additional check for this type of problem, your answer should be even. Make sure, did I get an even number? Yeah. Okay, so my final answers: 14, 16, 18. Okay, listing all of the numbers. Okay, and again, make sure they're all evens, add them together, make sure that you get 48. All right, we're going to try an odd example and then one that is a little bit more difficult. Okay, so we're only looking for 2 odd numbers this time. Okay, the first is always n. And now if it's odd, the second number, we're going to have to skip 2 spaces. Okay, it's not n plus 1. For odd, that's a common mistake. Okay, you're still skipping two spaces. You start at 1. How do you get to 3? Add 2. All right, so 2 consecutive odds, and their sum is 44. Whoops, this should be plus. All right, so our final answer, we want to make sure that it is an odd number. Okay, we get 21. So 21, and then 21 plus 2, 23. Okay, those are our 2 final answers for that one. All right, example number 4 here is a little bit more complicated. Okay, it's not as straightforward. It says 3 times the greater of 2 consecutive integers is 9 more than 2 times the less. Ooh. All right, so we at least know we're talking about 2 consecutive integers. Okay, so 2 consecutive integers should be n and then n plus 1. Okay, now how are they indicating the difference between the two? So what keywords are they using? It says 3 times the greater of 2 integers is 9 more than 2 times the less. Okay, think about that for a second. So if you said greater, the greater, and the less, okay, you're right. That's how they're differentiating between the two. So which is which? Well, the greater would always be something that's got plus 1 to it. Okay, so let's label each of those. All right, and now we're just going to translate the equation. 3 times the greater. 3 times the greater. We just want to make sure that we use parentheses so that we multiply the entire expression. Okay, is 9 more than 2 times the less. Okay, so 2 times the lesser. Okay, and we want to make sure, how are we going to factor in this 9 more? Okay, so if the 3 times n plus 1 side of the equation is already at 9 more, so we could add 9 over here to the lesser side to make it equal, or you could subtract 9 off of the right side, or the left side, I'm sorry. Okay, so now we can go ahead and solve our equations. Okay, I'm going to move my smaller variable. Okay, so we get our n, our first number, which is 6, which means that n plus 1 has to be 7. So our final answers are 6 and 7. Okay. All right, so that one was definitely a little bit more difficult. Okay, let's try another one of those. So the lesser of two consecutive even integers is 10 more than 1/2 the greater. So two consecutive even integers would be n and n plus 2. Okay, again, we're talking about the lesser and the greater. Okay, so let's label those. So this would be the lesser, because obviously anything with a plus 2 has to be the greater. All right, so now we're just going to translate. So the lesser is 10 more than 1/2 the greater. Okay, so the lesser is 10 more than 1/2 the greater. Okay, and we want to make sure that we use parentheses around the greater expression, so we make sure that we multiply the entire thing. Okay, I have some like terms here. And I have a variable on both sides, so 1/2 is the smaller, so I'll use subtraction to move that. Okay, so we would be we would be dividing by our coefficient, our 1/2, and when you divide by a fraction, it's the same thing as multiplying by the reciprocal. So long story short, we can multiply each side by 2 or 2/1. Okay, so I get my first number, n equals 22, which is an even number, hooray. So that means my first number is 22, and my second number, 22 plus 2, is 24. Okay, so really important that we get the correct expressions for each of our numbers, making sure whether it's even or odd or regular. And then we want to pay really careful attention to how we translate, okay, and if we have to use parentheses. So anytime that the expression for one of your integers is two terms, okay, meaning there's a plus or minus in there, you always want to use parentheses when you're translating. Okay. All right, so now this is the second part of our lesson here. We want to talk about age problems. So we do them similarly to consecutive integers, okay? But there's a little bit of a twist. So with age, okay, we're always going to figure out who is everyone being compared to. Okay, there's always going to be one person that everybody else is compared to, and that's the person that will represent your first value, your n. Okay, so whoever that person is, you're going to make them your n. All right, so let's read our problem. So Tara is twice as old as Gwen. Their sister Amy is 5 years older than Gwen. If the sum of their ages is 29, find the age of each girl. So who is everybody compared to? They're all being compared to Gwen. Tara is twice as old as Gwen. Amy is 5 years older than Gwen. So that means Gwen is my first number. She's my n. Okay, and then we translate from there based on Gwen. So if Tara is twice as old, Tara has to be 2n. And if Amy is 5 years older, then she has to be n plus 5. All right, and then this is similar to the first type of integer problems. The sum of their ages is 29. So n plus 2n, n plus 5, we're going to make our equation. Okay, so remember, guess and check is not allowed here. We do need our expressions, okay, which are these n, 2n, n plus 5, and then we need our equation. All right, so combine like terms and solve. So 1, 2, 3, 4n n equals 6. So that's Gwen. Okay, so that means 2n is 12. That's Tara. And n plus 5. $11, that's Amy. Okay, and those are the ages of our 3 girls. Okay, so always figure out who are they compared to, and that is your starting point. Okay, let's try another one. So Bob is 3 years older than Adam, and Carl is twice as old as Bob. The sum of their ages is 49. How old are each of the 3 boys? Okay, so who is everybody being compared to? Bob. So we can make Bob our n. All right, so Bob is 3 years older than Adam. So we would have to do n minus 3 in order to get Adam's age. And Carl is twice as old as Bob. So Carl could be 2n. The sum of their ages is 49. All right, we can begin to solve. Okay, so 49 plus 3 gets me 52. Divide. I get n equals 13. Okay, so that means that Bob is 13. Adam is 10. And Carl is 26. Okay. All right. So doesn't look like I see people for ages, but still kind of like an age problem. All right, so we're going to figure out the comparison here. So there's 148 students registered for American history classes. There are twice as many students registered in second period than in first. Okay, so instead of people, we're looking at class periods. So second period than in first, there are 10 less students in third period than in first. How many students are in each period? So which period are they all being compared to? They're all being compared to first. All right, so first period should be my n. All right, there are twice as many students in second period. There are 10 less in third. All right, so there are my three expressions. All we did was translate based on the comparison to n. How many students are in each period? Okay, and I know that there is a total of 158, so that's going to give me my equation. All right, combine like terms. Sorry about that. All right, and then begin to solve. Okay, so 168 divided by 4 gives me 42. All right, so that means that first period has 42 students. That means that second period has 84 students. And that third period has 32 students. Right, so those are my final answers there. Okay. All right, so those are your consecutive integer and age problems. All right, if you need to go back and review anything, please do so at this time. Make sure that you have your completed notes and write down any questions that you have so that you are prepared for our class. All right, thank you for watching.